Now we would like to basically go through and sequence our data according to our sequence and according to our ladders. This is the part where it gets a little iffy, but you really have to take some time with it and really look at it. So what you see down here, this lists off two rows. The bottom row is the actual sequence itself, and the top row is the sequence according to the ladders. So what you really want to do is make the top row match up with as much of the bottom row as possible. But the positioning of the bottom row has to be aligned with the ladders themselves. So this is where it gets a little tricky. So now what you're going to go through is you want to look and see where the sequence on the top row lines up with the sequence on the bottom row. So if we look in here, we can see that we've got some U peaks lining up, but we see we have our DDA ladder which finds U's and our DDU ladder which finds A's. We can see that it's not exactly the best lined up right now. So it's clearly missing some peaks in some certain spots. And look, here's a spot right now. Looking for unusual spacing. Essentially, if there's some unusual spacing, the CEQ just didn't get a big read for that specific nucleotide, so you really should go ahead and just add those in. So I think that there's some unusual spacing here, and I see some little bumps here, so I definitely say there's a peak here. So I'll go ahead and add those in. Alright, no problem. Oh, beautiful. Now, after I added that peak, look, we see our 3 U's here lining up with our DDA ladder, no problem. 1, 2, 3, 1, 2, 3. We have another U right here. Sometimes if you have a peak tied to the DDA ladder and the DDU ladder at the same time, it'll give you a little X. Basically what you can do is you can override that by deleting one of the peaks in the certain ladders. And since I know that this position right here is a U, considering that the DDA peak is very strong, the DDU peak isn't so strong, and the sequence itself lines up all around the positions. We know that it's U, U, U here. So we know that this position is a U. So I'm just going to go ahead and delete this box off the DDU ladder. There we go. Beautiful. So now you can see if you add in a couple peaks here and there, it really can help the alignment of the sequence itself. So basically what you're doing is you're going through and you're sequencing the data while you're lining it up with the shape peaks themselves. So depending on the number of peaks you have, which is vital because the first nucleotide in the sequence is always going to be the C. Any position number of the sequence is always going to stay tied to the same nucleotide. Makes sense, right? So the number of peaks you tie in here, basically what you're doing is you're telling the computer, hey, there's a nucleotide here, there's a nucleotide here, nucleotide here. So position number 55 is always going to be a G, say. So it makes sense that the number of peaks that you include in the top and the top filter is going to directly influence your sequence down here on the bottom. So basically what you want to do is you want to go through and you want to look for spots where the sequence isn't exactly lined up with the ladders themselves. So if we look right in here, we can see something very clear. We have our DDA peak, which finds U's, but we look here on the ladder. Our ladder is saying, hey, there should be a U here, but our sequence itself is off by 1 position. So that means that the number of nucleotides that we have found in the first filter is off by 1. So basically what we want to do is we want to shift these positions over to the right. But basically what we have to do is we have to do that by adding a peak. So we can see some irregular spacing pretty much right in here, and I'd say this is the cause of the shift because we can see here the A peak right here lines up perfectly fine, but we have our shift starting here. So a big factor is look for the positions where your data is lined up versus where it's not lined up, and then look in that region for a position where you think a peak might be that you might not necessarily be a very clearly well-defined peak. So I'd say there's definitely one in here. We'll see how that affects our sequence. There we go, beautiful. We have our U lining up with our U, A's lining up with the A's. You can add a peak on the DDU ladder to help tie in that extra A so you can visualize that sequence a little bit better. And now we're going through and we can see that our sequence is pretty well lined up for a couple ways. This is the best part, is that the computer can find a lot of the peaks for you, but it's really the very fine details, the small peaks that you find, that's really going to make this analysis work out well. So what you're looking at now is we can see in our DDA ladder we have our U's, 2 U's, a U, a U. We have our A in here, so it seems like it's still pretty well lined up in here. Alright, we're going through. And here's a spot where it's kind of tricky. We have a peak in both our DDA ladder and our DDU ladder, but clearly it isn't either. It's a C. So our data is still lined up because you can see that this DDU peak here lines up with these A's, no problem. Our U, there's a little bit above a bump here, so I would definitely say that this is a U peak. No problem. Alright, so our data still lines up, but sometimes you will get mixed signals in your ladders, so it's not always going to be 100% perfect with your sequence. That's where your discretion comes in. You really have to play it a little bit at a time. So again, we're going through, we still see, again here's a spot where we have a DDA peak and a DDU peak, but it is clearly a U. So we're going ahead and delete off this peak off the DDU ladder, thus giving us a U peak. Again, we can see here as we're going through, we have 3 U's in our DDA ladder, 3 U's down here, no problem. Again, our DDU ladder down here, we had a couple spots. I'd say this is definitely an A. So it seems like it's still pretty well lined up right here. As we come through, we can see, alright, we're still pretty well lined up, no problems. This spot, now we're getting to be a little tricky. There isn't really a very well-defined shift. Sometimes nucleotides can be off by 2, maybe even 3 positions, depending on how well you do the analysis. The number of peaks is crucial, again. So what we really want to do is we want to line up this data. We can see that we have a U here, and we have a DDA peak right here. So clearly this is our U right here, but it's off by 1 position. So what you might want to do, even though it doesn't necessarily look like there's a peak in here, what you have to remember is that the CEQ isn't going to be able to get 100% of every nucleotide. So what's most important is that you line up the shape data with the ladders for the sake of the ladders. Always for the sake of the ladders, because if one spot is a little off, the fact that you have the rest of it lined up is the most important part. So we're going to go ahead and just click a spot where we think we might be able to fit a peak. Even though it doesn't look like there's a peak there, it helps because we're adjusting the sequence to the ladders, which is the most important because the ladders will always be lined up with the data. The shift between the data and the ladders is never going to move. This is the only thing that's going to move. So you see here, now that we added this peak in here, we have our U peak lining up, no problem. We've shifted over to the right. And go ahead and click on this little guy right here. There we go. Now we have our U. As you can see, we have another shift going on right here. We have a U off by 1 of these U's, 2 U's, so 2 U's. So we're seeing there's a shift of 1 position here, and the shift also occurs here, and it's also in here. So I'd say somewhere between this spot and this spot, we need to add a peak. So it looks like there's some unequal spacing right here. I'm going to go ahead and just click on that, add that peak in there, and boom, look, our data lines up perfectly. We've got our U's lining up with our U's. Our A lines up with our A's. And that's most important. Even though these peaks might not be peaks themselves, the fact that this data point is over this ladder and that it's lining up with the sequence is the most important part, because that's the only way you can guarantee that that nucleotide is lined up with the right value of the ladder and the right shape reactivity. So we're going to go ahead and keep going. We see that we have, again, look, we have a shift again, A with the A. So clearly this A needs to be moved over another peak. So where can we add it? That's your discretion. Basically what you have to do is you have to look between our A here and our U's here where it's lined up, and somewhere in this region you have to add a peak to line it up. So what's going to happen is you're not necessarily confident that the peak that you're going to get is going to be the right peak, but you have to add it in again for the sake of the ladders. So what I just did is I deleted that peak off there so I could change the spacing a little bit to help me add in that extra peak. So I'm just going to go ahead and put this one here. You can see there's a little bit more of a gap now. I made a little bit of space. Our shift is still there because I only added in back the peak that I already took out. So again, I need to add in an extra peak to shift it back. So again, we'll add this peak in here. Boom, there we go. Our A lines up with our A peak. Our U lines up with our U peak. We can click on these just to confirm them. Beautiful. All right, again, we're still going down. We still see a good alignment. We have our U's, our U. And that again, sometimes it doesn't get on the first try. Again, we have a U right here, no problem, still lined up, looking good. Alright, now we're getting a little bit into a gray area. This is going to be a little tough because both our ladders are getting some signals from this area, so you really have to play with it and find out the best set of peaks where you're minimizing the amount of peaks you have to put in, but to still get it to line up with the sequence correctly. So we're going to go ahead, I see some spacing. What I'd really like to do here is I'd really like to make this A and this sequence underneath this peak right here. And that's just because I've done this experiment a few times, but I know that that peak needs to be there to help it line up. So I'm going to go ahead and drop in 2 peaks in here, replacing the 1. So there we go. And you can see there's some unequal spacing between the nucleotides, but what's important is that we're seeing that our data is helping to line up a little bit better. So we see that this U here lines up with this U, and we see our A is under a pretty decent sized A peak. Again, so here we have an A shifted off under this peak. So what we really like to do is get this A underneath this peak. So I can just go ahead and add a peak in between this area where I believe it's lined up and this area where it's not lined up. So this is the area where I need to add a peak. So we're going to go ahead and just drop something in there. You know, it's your discretion. You can play around with adding certain ones just getting it to line up. And there we go. It's still looking pretty good. So we have our A here. See, now the sequence is telling us that this A should be back 1, but given that this DDU curve is pretty fat, I would say that there's possibility of either or of those positions being that A peak. So I'm just going to go ahead and drop that there, and there you go. Just confirm that in. Now we're looking, all right, so we see that our data is looking pretty good through here. Towards the tails, it might get a little fuzzy, but you really can still get good peaks, just making sure that you line up your sequence correctly. So you really want to go through in here and just take out some of the spacing, maybe add some peaks, play around with a little, just to get to see what you can get to line up. And I'm saying, all right, this isn't too bad, but I'm going to go ahead and keep dropping a couple peaks in just to play around with it and see how I get to look. Because I see this A here, and I can tell it really wants to be under this peak. So I'm just going to keep adding extra peaks until we can get that A over there. So I'm just going to go ahead and drop this one in there. And there we go. We have our A under our A. We have a couple U's under here. So it's looking like our data is pretty well lined up with the ladders, and our sequence is also lined up with the ladders. And that's the important thing. So now we're going to go back. We can see that it's pretty well lined up along the bottom here. We're going to keep going all the way to the front because we didn't necessarily take care of the front part. All right, now we're at our front, and this is where the sequence begins, right near the primer front. So we can see that it's not too well lined up with the ladders. We still have a couple spots missing. I know for a fact that this sequence, if you'd like to check, starts with a CG positioning, and right now we're at a GUU. And right now I see these two U's here, but I see these two U peaks. So this is actually shifted over too much. So depending on which end of the data you're working on and where you add your peaks, it can shift the sequence a certain direction. So since we've already added all the peaks to the left, what I'm going to do is I'm going to drop a peak in here, and it's going to shift everything to the left. So there we go. So we added a peak back in here. We get our two U's to line up. We get our A to line up. And now I'm just going to go ahead and just finish off by adding a couple peaks in there just to make sure we get the beginning of the sequence. And there we go. All set, I believe. But if we add in too many peaks, we'll go ahead and just try, and I'll show you what happens when you add too many peaks. It changes the whole sequence on you. Now our entire data is misaligned, everything gets screwed up. That's because you put in more peaks than the sequence was allowed for. So you have to make sure that the number of peaks is very important. So what I'm going to do is I'm going to go ahead and undo that last peak I added because it screwed up the whole sequence on the bottom. So we'll go ahead and undo. Sometimes using the delete function can take a little while, but if you look, as soon as you do it and take out that extra peak, your sequence goes back to normal and it lines up with the ladders the whole way perfectly. So now what you want to do is, if you're doing multiple runs of these experiments, I already have a second set that I've already done. So this is our wild type +1, -1. We have a second run that we have completed +2, -2. So if you look, what you can do is you can click back and forth. Right now I'm just going to go ahead and just undo the fit. So if you click back and forth, you can see that essentially the peaks are in the same spots. This is how you get reproducible data from more than one experiment. You really need to make sure that the peaks are in the same positions between multiple experiments, even though the intensity changes. That's just, general variance. We want to make sure that the peaks are in the same spots. That way each nucleotide is basically getting the same reactivity value from the same position in the data. So again, you click back and forth. You can see the peaks themselves are getting a little taller. That's okay because that's just general variance in the data. But essentially, if you look, the peaks aren't moving. There's no peaks that are being added or deleted. You're really seeing the same shift between the data sets. So after you finish up and you do find all your peaks and you get it to line up with your other experiments, what you want to do is you want to come in fit. So now you want to tell the computer where you want to store the actual data from this file. So the fit is the fit to the data. What it's going to do is going to come through and draw a Gaussian. So I'm just going to go ahead and do my fit +1, -1. And that's your fit. Where your data is going to be stored is this mypeaks file. And the mypeaks file is where your actual values of the reactivity are stored. So we have +1, -1, no problem. Save. Go ahead and click append. And what it's going to do is it's going to go through each of these peaks and it's going to draw a Gaussian with its own standard deviation depending on the spacing between the peaks and other things like that. So we're going to click append. Now this is going to take a few minutes, so I'm just going to fast forward to the end.